Hey guys, I, Mr. Patman today, is going to teach something that you guys wait for so long. I'm going to teach something out of your syllabus! Give me a clap! Thanks. Okay, today I'm going to introduce you guys something that is the fastest in our universe. No, sorry, or land. Okay, it is
MAGLEV, magnetic levitation train or magnetic suspension train. MAGLEV is a super high-speed transport system which it has modified railways and the train itself is not equipped with wheels. This is how it looks like. MAGLEV move by levitation and propulsion, which later we are going to talk about this more in detail. On the other hand, maglev is a combination of superconducting magnet and linear motor technology. What is superconducting magnets? It is the magnet which will experience zero resistance when it is below its critical temperature. This highly increases the efficiency of maglev train and reduces energy loss. Some of you might hate history. That's why I make it a brief history here. In fact, it's still history. Maglev train was first described by Robert, who was awarded American rocket scientist in 1909. In 1912, French engineer Amélie had introduced eddy current repulsive levitation on maglev train. However, the amount of power needed is too high to run the maglev train, and also he faced the problems like lack of funding. The invention of maglev train keeps about 60 years. After that, the Japanese started their research on maglev transportation in the beginning of 1970s. But then, this was just the beginning. German, they took about 10 years to complete the construction of first track and the track in 1993 is the longest non-stop test was 1.674 kilometers. Although it is short compared to nowadays track, but it is still a good beginning. In China, 2003, they finished a 30-kilometer long track in Shanghai, and the train was propelled by electromagnetic suspension. The fun fact was, this is the first commercial magnetic levitation train in the world. This project cost over $1 billion. It's pretty expensive.
So maglev means magnetic levitation. Maglev.
So how does a maglev train work? It basically depends on magnetic levitation and propulsion. And simply levitation means float, and propulsion means propel forward. So in this case, it means by lifting something and propelling it forward by magnetic field with the presence of flowing current and with no other support. It also counteracts the effects of gravitational accelerations and any other accelerations, which means by that gravitational acceleration is a acceleration towards the earth, where when it's counteract means it opposes the effect.
So if you ever play with magnets, the same magnetic pole will repel each other and different magnetic pole will attract each other. So that will be the basic principle of our maglev, which with primary maglev system in Germany works by using the electromagnetic suspension, which is EMS.
To understand the idea of this maglev technology, some understanding of electromagnetic induction is required. Electromagnetic induction was discovered in 1831 by Michael Faraday. The basic idea is that changing a magnetic field will cause an induction in current. As shown in figure 1, when the magnet moves through the coil, which is the conductor, the magnetic field inside the coil gets changed and inducts the current. So basically is that when this permanent magnet passes through this conductor, cutting of magnetic flux occurs, thus producing induced current. So Faraday's laws of induction states that a potential difference is induced in a loop when the number of magnetic field lines passing through the loop changes with time. While Lenz's law at this side of the corner states that the current induced in a circuit due to a change of motion in the magnetic field is directed as to oppose the change in flux and to exert a mechanical force opposing the motion. So when you move the magnet in and out of the coil, changing of magnetic flux causes a change in the pole and change in direction of the current. So right now, we will be discussing the two types of maglev technology available in our society. The first one would be the electromagnetic suspension introduced by a German scientist. So the EMS system uses the attractive property of magnets. Since the same pole of magnets attracts to each other, the stator and the support magnet are attracted to each other. This causes the train to not land on the track. Also, engineers are able to adjust the power of magnetic field produced by electromagnets in the stator by altering its current in order to allow the maglev train to levitate into the air. As we can see, there is a guided magnet here on the side of the track that generates the magnetic force that prevents the train from moving side to side. Electromagnetic suspension technology is also designed in a C form to keep the train in the bounce. As we all can see, the train can't touch any side of the track levitating in the air because of the magnetic force pushing the train to the middle. So, at the other side of the world, the Japanese engineers have developed a competing version of maglev trains that uses an electrodynamic suspension system, which is based on the repelling force of magnets. So you'll be asking, what are the differences between the Japanese and the German maglev technology? The key differences that lies between these both technology is that Japanese trains use supercooled superconducting electromagnets. This kind of electromagnets can conduct electricity even after the power supply has been shut off. In the normal German EMS system, which uses standard electromagnets, the coils only conduct electricity when a power supply is present. By chilling the coils at frigid temperatures, Japan's system saves energy. However, the cryogenic system uses to cool the coils can be really very expensive. As the maglev train travels at high speed through the coils, superconducting magnets on the side of the train induce the current from the coils. A magnetic field is generated, as we all can see in figure 1. The EDS system works as an opposing pole of the magnetic field on the front of the train. So this will be the opposing and this will be the opposing. This way, the train can move without any other force while the train is levitating on the track. The magnetic field on the back of the train will change to the same pole, south, south, north, north. It will change to the same pole of the magnetic field on the train, which will be pushing the train forward. Now, the train has no friction levitating on the track, while with a magnetic system that makes it go smooth and fast, thus making the Japanese electrodynamic suspension maglev train the fastest ever land transport in human history.
One of the main differences between EMS and EDS
is that EDS uses superconducting electromagnets, so they have refrigeration problems. EMS, on the other hand, uses standard electromagnets, therefore there are no refrigeration problems. Another difference between the two is that EDS uses the opposing force between superconducting magnets on the train and electrically conductive strips or coils in the guideway to levitate the train. For EMS, the magnets attract up towards the laminated iron rails in the guideway and lift the train. It makes use of the attractive forces to lift the train as well as reduce friction. For EDS, the distance between the train and the guideway is around 10 centimeters. This system is stable and does not require continued monitoring. For EMS, on the other hand, the distance between the electromagnets and the guideway is about 10 millimeters. This distance must be continuously monitored and adjusted by computer in order to prevent the train from hitting the guideway. This system is unstable and would fail without this intervention. EDS also induces high-intensity magnetic field. Therefore, the passenger section of the train will have to be shielded from the magnetic field, or else it would be dangerous for passengers with pacemakers, and it may damage magnetic data storage such as credit cards and hard drives. The intensity of the magnetic field induced by EMS is low and comparable to the Earth's magnetic field. The advantages of maglev is that a maglev can travel a lot faster than conventional trains. Maglevs can reach speeds up to 500 km per hour, and the highest recorded maglev speed is 603 km per hour. Due to its lack of wheels, maglevs are quieter than normal trains. In theory, a maglev and its track would require very little maintenance. Since the train never touches the track, there is virtually no wear and tear. Maglevs also use 30% less energy as compared to normal trains, hence they are more energy efficient.
Maglev is a very advanced technology in the modern era. Therefore, a lot of modifications have been done using this particular concept for better future use. And some of the amazing and interesting examples include maglev cars, floating cities, and Skytrain. So the first one is the maglev car, and I think some of you might heard about it. So this idea actually came by during a challenge by Volkswagen for the China residents to draw out their idea of a future car. So this was the final concept taken and modified by Volkswagen, and it is based on magnetic levitation, which the car travels along electromagnetic road networks. So the interesting fact about it is that it can carry passengers up to a speed of 360 kilometers per hour. And it is a high-speed efficient transportation facility for future use, although it has not been proven, but someday it definitely will be. Okay, so the next one is the floating cities, which is also known as heaven and earth. So this is proposed by a Chinese architect named Wei Zhao, who was an honorable winner in the skyscraper competition in 2012. So it basically works when magnetic field is generated, it repels the gravitational force created by Earth and allows the floating island to remain suspended in air. It allows people to stay in an island floating on atmosphere quite far above the ground, where the air is free from any kind of pollution or impurity. Doesn't it sound amazing? So this idea came about because of the decreasing availability of ground on Earth due to increasing in population over the years. Okay, so last but not least, the Skytrain. Okay, so in my opinion, I think this is the coolest modification so far. So this is developed by an American company named Unimodal Transport Solutions. It is basically a two-passenger vehicle. It's a high-capacity and high-speed personal rapid transport system. It is propelled and suspended by maglev system, and it is laid out in a 1 mile by 1 mile grid throughout the city. So it has a large number of small departures or exit portals placed beneath the guideways, which is you can look here in the photo, and it is placed approximately every 400 meters or at every city block according to the concept. So in conclusion, I think magnetic levitation is undeniably an amazing and interesting technology with very big potential to build a better world. With this, it could be utilized in many daily life necessities ranging from transportation to household appliances and even decorations. And with the technology currently being expensive to implement, its potential value to be further explored has continued research. And further possible applications need to be explored for the sake of mankind.